All right, folks, let's recap on today's lesson. Today's lesson is built off of special right triangles, 30, 60, 90, 45, 45, 90, but the general concept is still the same, aka find the general formula for a two-dimensional cutout and then stack it from one bounds to another to create a three-dimensional volume. Okay, so let's do a little quick recap over here. SML means small, medium, large, respectively. Okay, so let's say you have a small side in this triangle of, let's say you have a small side of 1. To get to the large side, a small side of 5. To get to the large side, just multiply the 5 by root 2. Does that make sense? Okay, that's from IM2. Because how do you get from 1 to root 2? Multiply by what? Root 2. So same thing, 5, you multiply by root 2 to get to the large side. Okay, now if you're multiplying by root 2 to go from small to large, what do you do to go from large to small? Divide by root 2. So if large was 10 and you want small, you divide by root 2 and you get 10 over root 2. Does that make sense, folks? Okay. Now let's talk about 30, 60, 90. Let's say small side is 6. Okay. How do you get to medium side? Well, how do you get 1 multiplied by what gives you root 3? Root 3. So 6 times root 3 will give you the medium side. Does that make sense? Okay, let's go. If we want the large side, 1 multiplied by what gives you 2? 2. So what's your large side going to be? 12. Okay, let's go the opposite way now. Let's say that your medium side is 10. Okay. How do you get from root 3 to 1? What do you do? Divide root 3 by what? Root 3. So you would get 10 root over root 3. Does that make sense? But the million-dollar question is, what's the large side in this case? What do you do? Well, how do you get from root 3 to 2? You're like, I don't know off the top of my head. Okay, I don't know off the top of my head. So in this case, what you would do, and what I'm going to show you works for all the time. We just did a shortcut, but this way I'm going to show you works all the time. I'm going to just set up a proportion. Okay, root 3. Okay, root 3 to 2 is equal to 10 to large. Are you guys with me? That's a proportion. You cross multiply root 3 times L. 10 times 2 is 20. Divide both sides by root 3 and you get L equals to 20 over root 3. Okay, that's the long way which you need to do from going from M to L. This long way will work for all of these, but we did the ones before in our head because they're super easy. So in summary, okay, you can use the shortcut when one of the sides is 1. When one of the sides is 1. Okay, but if you have 2 sides, okay, if you have both sides not equal to 1, you got to use that long way. All right, okay, let's actually do some calculus now. Okay, so I copied and pasted this into your notes already. Okay, but let's actually do some calculus here. Okay, now this is basically the recap. I just did it in my own short way. Okay. Oh, here it is. Here we go. Boom. Boom. Okay, now, make sure it's still recording. Now, let's look right here at, let's get rid of this. All right. Let's get rid of these. Boom, 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 boom. there. Okay? Now, if you can't see in the back and you need to move to the front, move a little bit to the front, that's fine. Let's get some stuff out the way. Here's some standard information. Perpendicular to x-axis, perpendicular to x-axis. We good? Okay. We got the root x, negative root x. Boom, boom. Are we good? Okay. 0 to 4, 1, 2, 3, 4. 0 to 4, 0 to 4. We good? And eventually, we're going to integrate for the volume, stacking it from 0 to 4. We good? All right. So now, let's see how we imagine this. Okay. We have an isosceles right triangle. Do you agree that's an isosceles right triangle? Okay. I'm going to take this text box. I'm going to take that out of the way so that I can blow this up and make it bigger. Okay. Right here. Boom. Now, so isosceles right triangle, that means this is 45 degrees. Okay. Let me get my degree symbol. That's my degree symbol. 45 degrees, 45 degrees. Okay? Now, do you agree that the distance between pink to pink is going to be a clean root x? Do we agree? Okay. All right. And let's actually start off. Let me rewind. Let's say this is 4. The y coordinate, let's say that's -4. Can't we say the distance is 2 times this distance, which is 4, which becomes 8? Can't we do that? So this distance, okay, this distance 4 is basically the root x. So your complete total distance, over here, let's go like this. Boom, boom, and one more. Your total distance is 2 times root x for top pink to bottom pink, excluding middle pink. Does that make sense? Okay. So your base is going to be 2 root x for your base. Are we good? Okay. Now, this is your large side. Okay. Because it's across from the 90 degrees, which means this is your small side. Okay, because it's across from the 45. Okay, these are your small side. We got another one here. Now, going back to what I showed you earlier, in the 45, 45, 90, if we have a large side, in this case, of 10, how do we get to the small side? What do you do? What do you do? Divide by root 2. So watch this. To get the small side, I'm going to take this, divide it by root 2, and get this. Do you understand vertical pink? Okay. All right. Now, are these going to be, so we're all good on that I just erased. Do you guys understand why this and this are going to be the same? Because the angles across are the same. Okay. Base and height from 6th, 7th grade always need to be how many degrees from each other? 90 degrees. So we can use this as our base and height. Okay? This and this as our base height because of that 90 degrees. Okay? So we got base, we got height, or you can say height and base and height. Doesn't matter. Okay? They're both the same. That's why. Base and height, and a constant of 1/2 for the area of a triangle. We good? Now it's just simplifying algebra. This is going to be your two-dimensional formula that we're going to simplify. Your formula for your two-dimensional cutout. Let's actually do this. What's root 2 times root 2? 2. These 2's cancel. These 2's cancel. What's root x times root x? X. A clean x. Okay? Boom. Boom. So everything simplifies to a clean x. And again, we're integrating it from the bounds of 0 to 4, okay? 0 to 4, which is what it was given in the original prompt, okay? That was given, okay? And it's just algebra and it becomes 8. 2 more examples, okay? We're going to 30, 60, 90 now, okay? So for 30, 60, 90, watch this. Not hard at all. Let's get some stuff out the way here. Boom, boom. I'll need this eventually, but I don't want to congest your viewing space right now. Okay? Now, here we go, folks. Let's get that out the way. Let's get some obvious things out the way. Planes perpendicular to x-axis. Let's use a different color here. Orange. Perpendicular to x-axis. Boom, boom. Standard, right? Okay, 1, 2, 3. 0, 2, 0, 2. We good? Okay, 1, 2, 3, 4. Boom, 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 boom. Okay? All right, so Aiden and everyone else, watch this. Same thing as before. If this is 4, negative 4, total distance is 8, right? Okay. Do you agree that middle orange to top orange distance is going to be this function right here? Is the y coordinate, which is that function. Are we good? Okay, but that's only half the distance. So we need to multiply that 2 by another what? 2. So this changes to a 4. Oh, I got a 4 conveniently here. Okay, so that changes to a 4 right here for the whole distance between orange and, let's see if that works. Come on, technology, don't fail me now. Don't fail me now. There we go. Okay, for orange to, you know what I mean. Okay, orange to orange is going to be old blue 2 times another 2, which becomes red 4. Do you guys understand why orange to orange is that? Okay. Are we good? Okay, because we multiply the half distance, which is 2 root 4 minus x squared by another 2, and you get 4. Okay? So now, check this out. We did that, but we don't need that right now. What we're going to do, I'm going to zoom in on this triangle right here. I literally just copied and pasted and just dragged it over here so we can just focus on that a little bit. Okay? Now, one key thing that I forgot to say is that it's an equilateral triangle that pops out towards your face. Okay? So this pops out towards your face. Does that make sense? Okay? Now, we have 60, okay? 60, 60, 60, but when I crop out this triangle, I get a 60 here, but what's the top going to be? 30, exactly. And do you guys understand that if this is the full base, that's half the base of half the triangle? Because a 4 divided by 2 gives you 2. Are we good? Okay. Now, I told you earlier, if we have the small side over here, okay, of 6, how do you get the medium side? What do you do to get to the medium side? Multiply by root 3, okay? So I'm going to take this, right here, let me go blue here. I'm going to take that, and to get this, because this is the small side, okay, to get the medium side over here, I'm going to multiply this by root 3. Okay, I'm going to multiply that by root 3. Does that make sense? So this is our height now. Okay, this is your height. All right, that's the height of the triangle, which is, okay, whoops. Let's do it. Yeah, at this arrow here. Okay, so this is the height. Boom. All right, and this is your big base over here of the whole triangle. Base times height. Okay, I got a lot of highlights going over here. Let me actually erase some things here. So we got our height, which is our height, which is our height. Okay, we got our base, which is our base. We good? And then we got 1/2 as a constant. This whole crap right here simplifies to this. And remember, we are integrating from 0 to 2. Okay, make sure I'm still recording. 0 to 2. And we just copy this thing down right here. Algebra, yank this out, done. Okay, Aiden, you had a question? Okay, last example is like yesterday's last example. Okay, they're just going to try to be slick sometimes, and what they're going to do is, this is such a lame trick. Okay, what they're going to do is they're going to put a gap. You see that gap like yesterday? Okay, so now let's shrink these. Okay, well, let me just do it like this actually. Boom. And move this down right here. Okay. 0 to 1. 0 to 1, 0 to 1. Okay? Y equals to 1. Boom. Are we good? Last example, bear with me, folks. This right here, boom. Are we good? Okay? Now, equilateral triangle, again, means 60, 60, 60 for all the degrees. And this triangle's popping out towards your face. Okay? Now, let's do the same freaking thing that we did yesterday. Okay? If this distance right here, okay, so now I can put this away now that we understand how this graph was graphed. Okay? Now, if the distance between, let's go blue. If the distance between blue to blue is 5, what's the distance of middle blue to top blue, which is what we're interested in? 4. Okay? Because it's 5 minus 1. Does that make sense? Do you agree that the y-coordinate over here, the y-coordinate for this top blue is this right here? But we're not interested in, so basically this equation over here, that function represents blue to blue, but we're interested in middle blue to top blue, so what do we have to do with this function? Subtract 1. Does that make sense? Okay, just like yesterday. Now, okay, if you look here, dude, why is this not, there you go. Dude, it's not my day with technology today, dude. Okay, whatever, first world problems. Listen, so we're gonna look at this triangle over here. I got 60, 60, 60, but let's zoom in on this half over here. If this is 60, what's this top half over here? Or top angle? 30, are we good? Okay, and remember, blue to blue, okay, blue to blue is this whole thing right here, which is that whole thing right there. Does that make sense? Okay, but we're not interested in this, we're interested in the half of that, so we're literally going to put a half in front of this, okay? And that's how I got that for this half. Does that make sense? Okay, all right. So let me get that out the way. So now, again, to get from small side of a 30, 60, 90 to a medium side, what do we do? Small side to medium side, we what? What do we do, folks? Multiply by root 3. So I'm going to multiply by root 3. One more minute, folks. Bear with me. Okay. So do you understand how this became that to get from small to medium side? The fraction just changed the numerator. Okay. All right. Because remember, this is small. That's medium. Okay, so now we're ready to rock and roll, folks. Okay, we got the base, which is here, here. We got the height, which is here, here. We got the constant of 1/2. All this crap simplifies to this, okay? They extract it and we stack that. So this is the two-dimensional cutout that we stack from 0 to 1. 0 to 1 was given as our bounds, okay? And then they extract this out of the integral and it becomes this. And then this happens to be a calculator problem. They just put in using the integral function, second math. No, not even second. Just go math option 9. Okay? All right, folks, that's today's lesson. Thanks for tuning in.